Welcome to the chapter on energy systems. Understanding energy systems is crucial for mechanical engineering as they encompass the generation, distribution, and utilization of energy. This knowledge is essential for developing efficient and sustainable energy solutions. In this chapter, we will cover power generation, renewable energy sources, and energy efficiency. These topics are fundamental to understanding how we produce, use, and conserve energy. Power generation refers to the process of producing electrical energy from various energy sources. The main methods of power generation include thermal power plants, hydroelectric power plants, nuclear power plants, and renewable energy sources. Thermal power plants convert heat energy into electrical energy. The primary sources of heat in these plants are fossil fuels such as coal, natural gas, and oil. The basic process involves combustion, steam generation, turbine operation, and electricity generation. The efficiency of a thermal power plant can be expressed as eta equals the output energy divided by the input energy, multiplied by 100%. Hydroelectric power plants generate electricity by harnessing the potential energy of water stored in a reservoir. The process involves releasing water from the reservoir, directing the water flow to spin a turbine, and generating electricity. The power generated by a hydroelectric plant can be calculated using the formula P equals rho times G times H times Q, where P is the power in watts, rho is the density of water in kilograms per cubic meter, G is the acceleration due to gravity, H is the height of the waterfall in meters, and Q is the flow rate in cubic meters per second. Nuclear power plants use nuclear reactions to generate heat, which is then used to produce steam that drives a turbine connected to a generator. The key components include a nuclear reactor, a steam generator, and a turbine and generator. The energy released during nuclear fission can be calculated using Einstein's equation, E equals mc squared, where E is the energy in joules, m is the mass in kilograms, and c is the speed of light. Approximately 3 times 10 to the power of 8 meters per second. Renewable energy sources are sustainable and have a lower environmental impact compared to fossil fuels. The main types of renewable energy include solar energy, wind energy, biomass energy, and geothermal energy. Solar energy harnesses the power of the sun using photovoltaic cells or solar thermal systems. Photovoltaic cells convert sunlight directly into electricity, while solar thermal systems use sunlight to generate heat. The power output of a photovoltaic cell can be estimated using the formula P equals A times G times eta, where P is the power output in watts, A is the area of the photovoltaic cell in square meters, G is the solar irradiance in watts per square meter, and eta is the efficiency of the photovoltaic cell. Wind energy converts the kinetic energy of wind into electrical energy using wind turbines. The power generated by a wind turbine can be calculated using the formula P equals 1/2 times rho times A times V cubed times eta, where P is the power in watts, rho is the air density in kilograms per cubic meter, A is the swept area of the turbine blades in square meters, V is the wind speed in meters per second, and eta is the efficiency of the turbine. Biomass energy is produced from organic materials such as plant and animal waste. These materials are either burned or converted into biofuels to generate heat or electricity. Geothermal energy harnesses heat from the Earth's interior. This heat can be used directly for heating or to generate electricity using steam turbines. Energy efficiency refers to using less energy to perform the same task or produce the same amount of useful output. Improving energy efficiency is crucial for reducing energy consumption and minimizing environmental impact. The efficiency of an energy system can be expressed as eta equals the useful energy output divided by the total energy input, multiplied by 100%. For example, if a power plant produces 500 megawatts of electricity using 1,000 megawatts of fuel energy, its efficiency is 50%. Real-life examples of energy efficiency include LED lighting, which uses up to 80% less energy to produce the same amount of light as incandescent bulbs, and electric vehicles, which are more energy efficient than internal combustion engine vehicles, converting more of the energy from the battery into motion. By understanding and improving energy efficiency, we can reduce energy consumption, lower costs, and minimize environmental impact, contributing to a more sustainable future. Thank you for learning about energy systems. Thank you for watching this chapter on energy systems. We hope you found it informative and useful.